Hello, everyone. I only have 40 minutes and I promised to give 10 of them to Miguel here. So I'm afraid I have to start and get these lazy people getting in to sit down. Okay, that's my students. That's why I'm teasing them. Okay, so my job is to give you an outline of what's been happening in the land of OpenFOAM. But considering that we haven't been in Italy for 11 years and that we are actually in a church, I think we should say what's happening in the church of OpenFOAM. And this comes in two parts. The first one is the community, what's happening with OpenFOAM in general, some of the projects, and then I can't resist talking about some of the things that I've been doing myself. So let's start with that. The first thing is to thank our hosts. As you can see, we are at a touristy country, at a very, very beautiful city, at a very, very beautiful venue. And when I spoke to Joel a few moments ago and I asked him to organize another one next year, he said, no problem. Okay, I think he's kidding. But thank you. We appreciate the effort. So the second thing I noticed is that there are blue t-shirts in the audience. And for those old of us like Bernhard and Miguel who remember 2014 and Zagreb, we also had helpers in blue t-shirts and they call them Smurfs. So if they call you Smurfs, please don't take it personally. And some of my original Smurfs are still alive and here. So give me a wave, Tessa, Robert. There we are. Thank you. Cool. So let's get down to business. The first announcement is not really mine, but it's very impactful. And it has been announced about a week ago today. And that is that the ESI group is on sale. And there is a binding offer from a Californian company called Keysight Technologies Incorporated. So what that means is that the ESI group will change the owners. And with that, OpenCFD Limited will also change the owners. I think we have people from ESI OpenCFD in the audience. Maybe they know more. So please speak to them because this includes the chain of ownership of copyright and trademark of OpenFOAM. The price is, I'm not sure, either 912 or $921 million. So for those in the audience who need to make $1 billion quickly, please start your CFD company because we are running out of small CFD companies that are being sold. I would like to say that over the last decade, the ESI group and OpenCFD have been very careful custodians of the trademark, the software, the open source spirit, and the community. And for that, I am very grateful. So please give them a hand because this may be the last time that we are talking about that. I'm hoping that this will continue into the future, but in the short term, we have to worry about this. Okay, so last time with the change of copyright, things have definitely improved a lot, and I hope that will happen again for the ESI people. I don't see Uncle Fred in the audience. Freddy? Not here. Okay, so Uncle Fred online, please look after us while you're doing these negotiations. Okay, so now that you know in general what's going on, let's take a look at some of the issues that follow from that. The first one is OpenFOAM governance. So this is now working. We have new stakeholders. Recently, Huawei has joined, and this is great because it's one of those very large companies that have very large simulation needs that don't involve just CFD, but involve all other things, and they have quite significant financial muscle as well. So with our loyal contributors, including Volkswagen Group and all the others, I'm hoping that this will give us a new impetus. There are currently 7 technical committees and 5 special interest groups. My favorite one is, of course, turbomachinery. I can see Professor Håkan Nilsson in the audience waving to everyone. Okay, this is the turbomachinery guy. He can do everything. please speak to him, because what we need is not just software, but also documentation, validation, best practice guidelines, and showing off of some of the very best things that you can do with OpenFOAM. During the week, there will be update by the chair of the technical committees, which is Professor Gavin Tabor, and I haven't seen him in the audience either. The second thing that I would like to talk about is the OpenFOAM Journal. Okay, and the idea is that it is open access for readers and free publication, but it also includes the source code repository, validation cases, etc. And when I tried to publish a paper, I got told off quite badly, saying, well, where's the source code? Where's the test case? Because we need all of this. So this is the time for me to hand over to Professor Miguel Nobrega to tell you how this is really done. Thank you, Miguel.
Morning, everyone. Thank you for give me the chance to introduce the journal or talk you about the journal. I believe I will not introduce you the journal. The journal is already quite well known in the community. So give you first of all, one important stuff is the motivation of the journal. Why have we created the journal? We are here, we are in a conference, we are able to publish and talk about OpenFOAM related stuff. There are local user meetings, there are several events. And when we created the journal around 3 years ago, a journal for OpenFOAM specific stuff was a missing entity. So it was created, and was created by an initiative from the technical committee for documentation and tutorials, and we were supported by the governance, the OpenFOAM governance and the steering committee. For those of you who are not familiarized with the journal, it's a peer-reviewed journal related to OpenFOAM. It's just published online. We just have an electronic version, and we have two major keystones: benefit to the OpenFOAM community and reproducibility. So if any contribution accomplishes these two details, it will be published in the journal. It's free to publish and free to access, as Hrvoje just mentioned, and the authors retain the copyright. The copyright of the paper belongs to the authors. And we try to maintain the journal with the effort of the editorial board and the editorial advisory board, and a huge effort from the reviewers. We try to keep the journal alive with a small sponsorship. And since the beginning, we have been having the sponsorship of Compute and Upstream CFD. Thank you, the sponsors, for that. So additional details. It has an open volume. We are now, the volume open is the 2023. The papers, that means the papers are immediately added to the journal right after acceptance. There are 3 main sections: full papers, technical notes, and review papers. I will not cover the details of it, but if you go to the website that is shown in the slide, you get all the publication. It has an ISSN, and we have DOIs. We still don't have the impact factor. We need to have 3 years after the first publication that took place in September 2021. 2020, and after 3 years, we'll have next September we'll apply to have the impact factor. The workflow is equal to a regular journal, so we have the submission, then there is a review process that is double blind, so the reviewers don't know the authors, nor the authors know the reviewers. This is a model I've been using since the beginning, and it seems to work very well, and would like to keep it. Then there is a regular production and the actual publication of the journal. The editorial board is maintained by a group of persons well known in the community and covering different areas, and the same applies to the editorial advisory board. a group of 30 persons from the community, also from different places and covering different areas of interest. There are a number of guidelines. We have the templates. For the templates, there is the LaTeX template for the journal publication that is available in GitHub, and you also expect everyone from the community to contribute to it and to help us improve the template for the journal if possible. The website is quite minimalist. It's based on the Open Journal systems. That is a framework created to manage journals, and I've been using it in this. It helps a lot on the review process, and for each paper, these are the last ones available in this year volume. For the papers, we have a number of information that I'll cover later. There is also a YouTube channel associated to the journal that contains a presentation of the journal, some guidelines, and we also have the recordings from the last workshops, OpenFOAM Workshop 16th, 17th, and hopefully we'll have also the recordings from the OpenFOAM Workshop 18th soon. Something we created this year was the abstract videos. Currently, it's possible for the authors to have abstract videos for the papers that will help disseminating the papers themselves. For you to have an idea, the YouTube channel has more than 1,800 subscribers and more than 51,000 views. We have also a LinkedIn profile where we disseminate information about the journal, one post per week, and that channel has about more than 7,000 followers. There is also a newsletter that was created this year. We try to send a newsletter every 2-3 months with the updated information about the journal. So if you subscribe the journal, you'll be receiving the newsletter. So the current state of the journal, we have at the website, we have more than 1,000 registered users. More than half apply to review, and this is very important because the journal really depends on the viewers role. We have 19 papers published, 3 in production, and 9 under revision. For you to have an idea, the acceptance rate of the journal is around 50%. So the submitted publications that go on review afterwards, half of them are published. Some statistics about the views for you to see that the publications that are available in the journal are really visible. So if you publish in the journal, we are pretty sure, we are confident that your work will be known by the community. So we have more than 41,000 views on the publications. A quick overview of the site. We have every paper as the regular page and a discussion forum associated to the paper. DOI, information about DOI, the paper itself, the discussion forum, link for the discussion forum you are seeing on the right, and the data related to the publication, the case studies and the source code. You can also, sorry, the previous one I was not seeing very well. It was the abstract video, the link for the abstract video. This one is the link for the source code and case studies. How to cite the publication, it's also available. And okay, this is the section of the paper. It's full papers, we have different sections. And the copyright, as I mentioned, the copyright belongs to the authors. We have a DOI, so are issuing DOIs for the every publication, and we have a plagiarism detection tool that we use this service that is provided by Crossref. So one additional new is that the cover you have seen so far is a temporary cover. So there was a call for covers, and the winner got the cover during the year. But at the end of the year, we'll select one of the images related to the actual published works to have the publication. And the winner for this year temporary cover was Joshua Miller from the UK. Thank you for the very nice picture that is we have been using for the journal during this year. So to finalize the next steps, what we expect from you, please register in the website. Obviously, submit your contributions, contribute to this project that is a community project, and help us reviewing papers. This is also very important. Also associated to the 18th OpenFOAM Workshop, there is a special issue. You can apply, the information is in the website, and the deadline for the submissions is the end of September. So to finalize, your opinion is very, very important for us. There are a number of persons involved in the journal that you can talk with. Please let us know what you like, what you don't like, what we should change. Any ideas are very, very welcome to improve this project. And please do not forget, submit your contributions. You'll have visibility in the journal, your work will be visible, and what you can publish in the OpenFOAM Journal, I'm pretty sure cannot be published anywhere else with the details. And this is it. Thank you.
Thank you very much, Miguel. Okay, so there was CFD before OpenFOAM, and there were journals before the OpenFOAM Journal. And what you can see here is how the team looked at what they thought was wrong with the journals and did things better. I cannot tell you how impressed I am, and I look forward to reading your contributions to the journal. Talking about the community, we now have lots of events. So as you know, this thing started from a back garden at the University of Zagreb in 2006. And in 2008, I started running the summer school because there were so many desperate people trying to do OpenFOAM on their own. And now it is so much easier and nicer. So on the next couple of slides, I picked up a couple of few of these events that have been happening, which impressed me so much. And the first one is by Holger Marshall at Technical University Darmstadt. Holger, can you give me a wave? There he is. Okay, so he said, let's do multi-phase flows, but let's do them properly. And he set up a 3-day short course inviting 16 international lecturers. And about 3 weeks before the course started, he had to start rejecting people because there was only 110. Now listen to this, 110 places in the rooms. So Holger, I was so impressed because all of the lectures that you had were absolutely first class and much better than many of the conferences that I usually go to. And two more things to say. Please do it again. Get yourself a bigger church. And you can see here it says Dr. Holger Marshall. So if we have Dieter Bote online, Dieter, please write to me why this guy is not a professor yet, because that needs to be sorted out. So thank you, Holger. See you again in Darmstadt next year. This year, I'm again running the summer school with individual one-on-one supervision. We have about 14 people. We will spend 2 weeks in Cambridge. The idea is that people bring their own projects and then work under the supervision of myself and my doctoral students to help them out with modeling, programming, etc. And it has proven very successful. I hope there's going to be one next year. It is usually announced for my birthday on the 1st of March. So please keep an eye open for that one. A few more things. So the first one is a high performance computing workshop organized by the ExaFOAM project. One just happened on the 12th and the 13th of June, and it was virtual. I will say a bit more about the ExaFOAM project. So please keep an eye if you want to know how to do HPC. This is one of the best things that you can do. I would also like to mention Andre Weiner and Tomislav Maric doing something that I know very little about, which is the machine learning hackathon. I think Andre, can you give me a wave? You're providing training either today or tomorrow, I'm not sure. And I'll definitely come and see what you need to do. Okay, maybe it's the future, maybe it's not, but I can't afford not to know. Okay, and the third event that I have listed here was in Chongqing, China on the 17th and 18th of June, organized by Professor Hrvoje Jasak from National University of Singapore on combustion. And again, the guy started from nothing. He invited a bunch of people who have regular seminars. I still get an invitation. This is first class. It is designed for combustion applications, and I'm very impressed with the kind of people that he got to present. So please join him virtually. I was really sorry I couldn't make it this year, but hey, that's life, okay? The message from these slides is that there is a lot of very high quality stuff, and that we finally got to the stage where you don't need to listen to the old horses like me to teach you about OpenFOAM. There is so many people in the community who are very competent and who are doing first-class stuff. Okay, so ExaFOAM project is an Euro HPC project with the idea of pushing OpenFOAM towards exascale computing. So it turns out that we were at 0.1 exaflop at the start of the project, and some foolish person promised to give factor of 10 to a factor of 50 speed up, which would be really impressive, and everybody's been working very hard on that. The project has got another year to run, and we are pushing towards using tens of thousands or hundreds of thousands of cores in parallel with the software that started in about 1992, which is, oh my God. Okay, so the obvious way of doing that is to throw everything away and start from scratch. But apparently this OpenFOAM thing is quite resilient, but it requires a bit of tender loving care. So here I have just a few of the activities like parallel I/O and data management for our joint, detailed code profiling. We have partners from the Supercomputing Center in Barcelona. Do we have anyone in the audience? No? Okay, so what the lady did is she profiled the code on a few hundred cores, and she showed us who is waiting for whom in parallel, which is very different from who is waiting from whom in serial. So now there is lots of stuff that needs fixing. And we also have some work from Italy, from Politecnico di Milano, on porting GPU versions of chemistry ODE solvers, and my favorite bit, linear equation solvers for exascale. Uncle Henrik from Wikki GmbH is responsible for validation cases where we have micro benchmarks and grand challenges. Uncle Henrik, give me a wave. There he is. Okay. So the next time you have free CPU time on your computer and you need a 600 million cell case to start, he's the guy to talk to. Okay. So to give you an idea of what's on my list, I'm responsible for task 4.1, and the contributions include a number of people and involve stronger coupling solution algorithms for pressure velocity, new numerical algorithms for linear solvers, coupling to external linear solvers, both on CPUs and GPUs, code performance on reactive flows, efficiency of non-conforming mesh interfaces, load balancing, and adaptive mesh refinement. And as you can see, there is enough here to keep you awake at night, which it does. Okay, so about a month ago, I saw a big announcement on the internet about something called PUMA from ANSYS Fluent, talking about polyhedral unstructured mesh adaptation. And it made me feel so good about life. Okay, so what they can do is they can create a polyhedral mesh and they can refine it and coarsen it. oh my God, we had that 5 years ago, right? So here's a little movie, again from Holger, showing you what all of this stuff looks like in OpenFOAM. But on top of that, it has got dynamic load balancing as well. So the different chunks here not only rebalance, but they send stuff from a small number of from one set of from one load balance to another, and all of this is working. This is still on my list. We are porting this into OpenFOAM. There are people in the audience who hate me because I'm late, but I wouldn't want to be late, Professor Jasak, and please bear with me while this is happening. Okay, so what else is on my list? We have a new multi-scale, multi-physics application framework, again done in collaboration with Technical University Darmstadt, including block matrices, coupled matrices, which allow you to couple multiple equations on different domains, like in conjugate heat transfer or conjugate electromagnetics or any other conjugate problem. And we also have the block solution for anything from block systems of chemistry to pressure velocity with interfaces and coupling. And Holger and his group has taken on them the task of packaging this up under interfaces that allow you to do all kinds of simulations under a single framework. And I was so impressed with that. The paper, I'm not sure whether it just came out or it's in the process of coming out. So keep an eye, because this is giving us another layer on top of everything that we missed in the past. The other thing that is on my list are the GGI and AMI non-conformal mesh interfaces. And this comes in a number of layers. The first one you've seen within the ExaFOAM project, where this doesn't scale properly. So if you run on a couple of hundred cores, it doesn't really matter. If you run on to 50,000 cores, this will be the limiting factor that's slowing you down. But apart from that, I had minor issues with mass conservation and linear solver performance for a long time. And as Snoopy would say, the best way of fixing the problem is to run away from it. So I kept my eyes closed and I said, oh, it's fine, it's fine. And then a customer at Wikki looked at us and he said, we have mass conservation errors of 0.2% across the interface. This is unacceptable. And you know what? They're right. Okay, so having studied this, it turns out that there is a fundamental problem with the way GGI interfaces were formed by grouping faces from intersection facets. And that requires a rewrite, because in diffusive transport, I can't fix it the way it is. So Håkan, this is something for us to talk about, because Håkan and Martin Badouin are looking at transferring some of this capability into OpenFOAM ESI version, so that we can benefit from mixing plane interfaces, partial overlaps, and all the other things that we've been working on. Right. So one of my passion projects is Naval Hydrodynamics CFD. So anything to do with waves, ships, propellers, floating objects, 6 degrees of freedom, and various other things has bothered me for a long time. But this is one of the very conservative industries where people have only just started applying CFD to the level that automotive industry would consider to be routine. And one of the problems with it was that for a very long time, Naval Hydrodynamics CFD involved modeling stuff that they had in a towing tank. So you would have a 2, 3, maybe 9 meter model of your ship. You would do CFD on that, and people would justify it by saying, well, that's where we have experimental data. Well, I've got a surprise for you. There is no 9 meter ship that's of interest. Okay, so the one that you have here is the MV Regal ship at 168 meters. But the problem with that baby is that you don't have any experimental data. So last year we had Dmitry Pankratov from RINA presenting at the conference in Cambridge, and he spoke about what we need to have in order to validate and verify CFD at full scale. And of course, you have to measure the performance of the ship on the full scale. And this is exactly what they're doing. So this is the largest joint research project ever, I think, in the naval hydrodynamics industry. It involves various designers, shipbuilders, classification societies, and I think Marco will correct me, there's 54 partners so far, and they are all doing beauty contests of comparing their CFD simulation at full scale. Why is this important? Well, your Reynolds number is 10 billion, okay? The scale of the ship is such that you have to account for the waves. And if you want to look at energy-saving devices, fouling, trim optimization, and various other things where the Reynolds number, turbulence, and flow matter, and not just the waves, you have no choice. Okay, so what you can see here on the left-hand side is the CFD model, and on the right-hand side is the real propeller with PIV measurement rigs being put around it. Okay, they're currently doing 5 ships, and the one that impresses me most was a cruise ship. So they spoke to people in order to get the cruise ship and measure some data on it. And then they had to pull out in the last minute because the route, I think, from Le Havre to Amsterdam went through shallow water. And they said, well, we can't measure in shallow water because this is not representative data. And the ship owner said, okay, well, we'll change the route. And it turned out that they did the experiment on a full-size cruise ship with passengers on board. Now, how cool is that, right? So I'm really looking forward to doing much more on that. Okay, so about 5 years ago, I started talking about overset mesh and how this is necessary and that it requires work. Currently, we have 2 implementations, one in OpenFOAM ESI version and one in FOAM Extend. But how good is your overset? Okay, so here I'm pulling a little movie which was done as a part of the NATO Advanced Vehicle Technology project. And what we needed to do is to do a simulation of this quite weird looking ship in waves. The requirement is that the ship will do a zigzag maneuver and it has to follow the trajectory. The wave state here is quite simple. You can see the moving rudders and you can also see rotating propellers. Okay, for those who are really good at ships, you will notice the propellers are spinning too slowly. This is because we are using a trick called partial rotation, where one part of the rotation of propeller is done by moving the mesh and another with an MRF zone so that you get the thrust and torque as you should, but you also have the intermittent effect of the propeller blades hitting the rudders, okay? This belongs to Sanjo Jurašević, who is just writing up his PhD at the University of Zagreb. And it came just like that. Oh, by the way, I did the simulation. It has got 4 levels of overset. This is about, I think, 7 million cells in 3D, transient, and it runs really quite beautifully. We had the conference for the NATO AVT in London. And I said, okay, well, why don't we do this one in an irregular sea state? So rather than giving waves that go nice and up and down, you create a potential field of realistic waves that you can see at the sea. And I was told, no, don't do that. We are planning that for the project that will start in 2027. Okay, so well done, Sanjo. I am very impressed with his work. Okay, there is a paper on the partially rotating grid method in ocean engineering. And Sanjo will be annoyed with me now because the graphs that you see here at the bottom are not actually the zigzag maneuver. They are the turning circle, but they looked prettier for me. And anyway, what do you know? Okay, so this is how it works. This is a few hundred cores. It parallelizes properly. Okay, and to finish things, a few things that are really bothering me at the moment. So the first one is the project on ice accretion. Okay, and the idea is that you have an aircraft flying through a cloud of supercool water droplets, and you need to find out how this ice will deposit on the wall. Okay, I had to learn things like the difference between glaze ice and rime ice, where one basically is the particles that solidify on the impact, and the other one is that the particles that hit the wall actually turn to liquid and then create a liquid film along the wall. On top of that, you will add ice suppression. So through the wings, you will blow air or do something similar, maybe have electric heaters, which will melt the ice and resolidify the ice. And finally, the change in the wind geometry influences the fluid flow. And you can't do that just by pushing the mesh out using mesh deformation. So within this project, I'm using the immersed boundary surface. So for those of you who still wonder, what do you need a library for? This is it, okay? So in order to model the rain or the freezing droplets, you need a polydispersed or Eulerian multi-phase flow, either one directionally coupled or bidirectionally coupled. Then you calculate the impact enthalpy, taking into account the kinetic energy, which tells you how much of the particles are liquid solid. The solid particles accumulate on the wall. The liquid particles go into the liquid film model, which is now available everywhere. And then you can melt and solidify that. So some of the images of the simulation will look like this. And what you can guess is that we have about a year worth of validation verification work. But just by virtue of having all components as libraries, we can put together a tool like that. A few more things. So you know that I travel a lot, which is usually a bad idea. The bad idea about traveling is that you meet people like you who tell you, oh, by the way, this solver of yours, it's a bit rubbish for ABC. And in this particular one, I had a guy who was doing combustion, and he said, my other solvers are so much better at combustion than OpenFOAM. What's this garbage that you put in? And the first answer is, yeah, whatever. Okay. But then I wanted to do some combustion, looking at quasi-steady state problems and looking at the problems that involved very large differences in the time scale, like hydrogen combustion or steam reforming processes. And the solver keeps blowing up. So here you have the equation that shows you DDT convection diffusion and the right-hand side term, reaction rate, which is calculated by taking a mixture in the cell and then solving an ordinary differential equation to find out how that mixture is going to burn. You do that for the length of the CFD time step, and then your source term is the difference between the final and the initial state. As you increase the time step size, the solver blows up. Then the ODE solver blows up. Then you find out that the results are dependent on the time step size and the whole thing is unstable. And I want to run this at the CFL number of 1 million because I want. Okay, so it turns out that chemistry RR is actually a volume scalar field. So that means that my mass concentration will not be bounded between 0 and 1. There is nothing in the ODE solver that will take into account depletion. On the other hand, in steady state, my reaction rate should stay constant, okay? The thing that really blew me is that you have this natural condition which says that the sum of mass fraction must be 1. Well, it isn't. Okay, so you can easily have 5 species with mass fraction of 1, giving you the total mass fraction of 5. And what do you think how the solver behaves? Terribly. Okay, so this needs to be fixed. And the steady state solver is one of my pieces of work in progress on the table. So finally, some of the stuff from my students. Okay, we have Robin, Fran, and Luca here in the audience dealing with high-speed bearing contact lubrication. And in the past, I spoke about you have a very thin liquid film, micron size or 0.01 micron size. You have 2 solids which are deforming elastically, plastically, blah, blah, blah. But it turns out I'm actually a dinosaur. So the kind of stuff that these people are doing are shown here, involving things like tribofilm. where you make your material out of steel, but then out of oil, you create a sulfurous layer on the two surfaces, and the friction actually happens within the sulfurous layer. The second one at the bottom is from Fran, and the problem is apparently related to electrical vehicles, where you have the RPM speed of 100,000 RPM. No, don't ask me which piece of equipment that is, but apparently this is a real problem. So suddenly your lubrication problem becomes a cavitation problem, okay? And they have run away from me so quickly that I have to pass that on to their presentation. So Fran, Robert, can you just give me a wave? There they are at the top, okay? So please go and listen and find out what they do. Okay, and finally, a very interesting green project talking about CO₂ sequestration. Okay, so this is done in collaboration with KAUST, Uniperugia, and a very impressive guy called Larry Baxter from Brigham Young University, who also runs a company. So recently in Saudi Arabia, you're no longer allowed to build an electrical plant based on combustion if it doesn't have 100% CO₂ sequestration mechanism. So the mechanism that we are exploring involves injection of cryogenic droplets into the system, and then you will have condensation and sublimation of CO₂ on the outside surface of the droplets, which you collect at the bottom, you press, which separates your cryogenic liquid from your CO₂ in liquid form so that you can get rid of it. So currently we are working on that by looking at the problems of desublimation and moving that onto the droplets. The job at Cambridge is to do that with direct numerical simulation and create the models which will push towards LES, where you can optimize the whole procedure. So if you really want to imagine what it looks like, my boss said, I know what you do. You make snow, okay? But this time you make snow out of CO₂. So enough about this, maybe a few of outstanding items, okay? So finally, after a long delay, the book of abstract of the 17th OpenFOAM workshop is released in the PDF form. I'm not sure whether Miguel's got a copy on his website, but we'll sort that out. Joel, please do one like that as well. And we are going to have a meeting this week about hosting of the 19th and maybe even the 20th OpenFOAM workshop. So if you're interested, bringing us all into your church, please speak to Joel so that he can do the necessary organization. Final thoughts about working together. So recently, I've been speaking to various companies that I never heard of, like a number of Formula One teams and smaller racing teams, and even people like the UK Atomic Energy Agency. And what they tell me, yeah, OpenFOAM, yeah, we use it all the time. And I ask them, well, who do you talk to? And the answer is nobody. It just works. Okay, so if you're using OpenFOAM and you know people who are benefiting from it, encourage them to join us, because I'd love to hear about what people are doing, unless you're really making nuclear weapons, in which case, keep them to yourselves. So thank you for all that. Thank you, Joel, one more time. It is a pleasure to see all of you. And now it's my time to listen about what you're all going to say. Thanks.
Yes. Thank you for a very nice overview. All right, so from the local organization, we wanted to give a small gift to the people doing the plenary lectures. And what we came up with was a book. So there's a lady called Enrica Monzani. She's a photographer, a food blogger from Genoa. She has a food blogger called a website called The Small Kitchen in Genoa. And she actually translated the local classical recipes of the food in this region to English. And so this book is full of very nice pictures from a region about food and recipes, both in English and in Italian. So please have a copy. And since we had two, unexpectedly we had two, so Miguel, a copy for you as well. Okay. Thank you.
Okay, thank you. So now time for questions.
Be nice to me. Well, in that case, don't be nice to me.
Well, that's one. What about one fun all this thing that people have been talking about?
It's working. We are working quite hard. Okay, but moving various items from various versions of code together takes time. You have the finite area method. Now we are going to do polyhedral refinement. There is lots of work on liquid film that has been done. There is various bits of fluid-solid interaction. Håkan is doing the work on turbo machinery. You know, we are talking about 1.5 million lines of code, and I can't give up mine just like that because people keep putting bugs into codes and I need to get them fixed. Okay, I think we would all benefit from getting one development stream and getting things sorted out, but this is taking time. I'm all for it. So if you can keep me on holidays for the next 2 years, we can make it move faster.
Thank you for a nice presentation and an overview. Just regarding the question we just had here, maybe it would be nice to hear. I know people who want to port stuff from, say, foam extent to the open ESI version or vice versa. And sometimes they are unsure whether that is politically acceptable. So maybe if you could just say that that is actually the case, that would be nice.
Okay, so formally there are no issues at all. The software is open source. You can copy the whole thing, a part of the thing, move it from one version to another version, etc. Okay, and nobody has the right to complain. Okay, I'm sure ESI will also have issues about accepting anything. And if you take a look at any of the headers of any of the work that I do, which is not work for hire, it will be under the open source GPL license. Okay. What I would like is to people to say, hey, I'm doing this. How about you help me? And the reason for that is not to ask for someone to approve, but actually to find out what's going on. Okay. And this is the reason why I, for example, mentioned GGI today, because porting the one that I think is broken is less useful than working together towards a new one that works better. I think both you and I agree that having one single development line and one single access point would be great. Okay, but I think Henry Weller is a much bigger problem than I am on that matter. And my biggest limitation is time. Okay, so I'm all for it.
You have mentioned the overset method, and you've been showing a couple of examples. And in our experience, the ESI1 implementation, ESI1 implementation is not extremely efficient, I would say. So I'm assuming that the one you have in the extend is probably doing better. So is there any chance that we'll see some improvements in the future?
This is 144 cores. We can run it to about 500 cores without problems. And then I need the equivalent of the ExaFoam project to sort out things, okay? Currently, I'm talking to Naval Hydrodynamics customers to make it even better, because if you're an overset expert, you will know that sometimes all the codes, apart from star CCM plus, get these little pressure fluctuations, and I'd love to see them fixed, okay? The difference is that the two implementations have been developed at the same time, independently from each other, and we didn't talk to each other, which is a disaster. Okay, so I'm hoping that in the spirit of what I spoke to Johan, that will not happen again. Okay, but how we can fix that right now, I don't know. As I said, foam extend version is completely open source. There is an issue of porting because you have to change a number of interfaces, but the way it is supported is by using the coupled LDU interface field, just like processor or GGI AMI, whereas overset in the ESI version is hard-coded into the matrices, which makes it much less flexible. Okay, I'll stop there because I can't convince people that they have done the wrong thing. And the fact that we both need to work to improve them is always true.
Okay, I think we need to move to the next speaker. So thank you very much again to Prof.